Before we look at the questions in this video, we're first of all going to look at the formulas that are going to be provided to us in the formula tables, which we'll be given copies of when we're going into exams, but we can also purchase to use in class. So the first box up here is the information on triangles from the length and area section of our formula book. And it clearly shows how the sides are laid out in a triangle, how they're labelled, and how the angles are labelled in relation. So for example, if we've labelled the sides A, B and C, you notice the angle C is written as a capital letter and it is directly opposite the side C, which is written in a lowercase. We've got two formulas for area in this. We've got one of them which is 1/2 AB sine C. In other words, it's 1/2 multiplied by the length of two lines multiplied by the sine of the angle in between them, and we can see this in the diagram. And the other formula we have is the root of s times s minus a times s minus b times s minus c, where a, b, and c are the lengths of the three sides of the triangle, and s, we can see written over here on the right, is a plus b plus c all over 2. And if we look down to the next section, these next two sections are from the trigonometry section. The first one here is useful because it shows us a diagram of how all of the sides and angles are labelled in relation to each other in a triangle. Then we're once again given 1/2 AB sine C for our area. We're then given the sine and cosine rule, which are stories for another video. And then we look at our right angle triangle section beneath it. We've got Pythagoras theorem and how we calculate sine, cos and tan if need be in a triangle like this. But let's get on to our questions, and we're going to get the area of some triangles now. So this is questions 1 and 4 from exercise 4.4 in Project Maths 3A. So in the questions, we've got to find, correct to 2 decimal places, the area of each of the following triangles where the lengths of the sides are in centimeters. So let's look to question 1. So unlike where we did this we would have done this previously in geometry, we don't have a perpendicular height. So we're going to have to use the 1/2 AB sine C formula, which you can see over here on the right. So it's going to be 1/2 times the length of these two lines, so times 16 times 20. And then that's going to be multiplied by the sine of the angle in between them, which is sine 30. And we can literally just stick that straight into a calculator as is. It's 1/2 times 16 times 20 times sine 30. And our answer for this in our area is going to be equal to 80. And because the question specifically said the lengths of the sides are in centimeters, that means that this is going to be in centimeters squared for our area. And for question 4, we're going to use the same formula. But this time around, we've got to actually calculate the measure of the angle in between them because we aren't given it. We're given 2 sides, we're given 2 angles, but not the angle in between the 2 sides. And we don't get to just pick which angle we use. It has to be the angle that is between the 2 sides that we are given the length of in order to get the area. But the way we can figure that out is that all 3 of these angles should add to 180 degrees. That's what happens within triangles. Which means our missing side down here is going to be 180 minus 64 plus 72. In this case, it's going to be equal to 44. So over here, this is 44 degrees. And now we can put that into our formula. So it's going to be 1/2 times 8 times 6 multiplied by the sine of 44. And again, that's going to go straight into our calculator. And we're going to get 16.6718 ... But you notice the question said correct to 2 decimal places. So in this case, our area is going to be equal to 16.67 centimeters squared. Like that. So that's how we would use the 1/2 AB sine C formula. Now for our next one, this here is question 7 in exercise 4.4 in Project Maths 3A. And we've got to get the area of this triangle. Now we don't have any angles given, We don't have a perpendicular height this time. So what we're going to have to do for this is the formula we see over here on the right. So since we need S to start, we're going to start off by figuring that out. And if we just label our sides, we've got A, B, and C, like that, which means that S is going to be equal to 12 plus 8 plus 6 all over 2. Well, 12 plus 8 plus 6 is 26. 26 over 2 is 13. So our S is equal to 13. And now we're going to put that and our values for A, B, and C into our formula to get our area. So A is going to be equal to maybe 13 times 13 minus 12 times 13 minus 8 times 13 minus 6, and that is all under the square root, like that. Let's work that out. So that's going to be 13 times 1 times 5 times 7, all under our square root. So you're going to get A is going to be equal to the root of 455. And we can get our calculator for that at this point. The root of 455 is 21.330 ... But you remember from above we're asked to get these to 2 decimal places. So A is approximately equal to 21.33 centimeters squared. And that is that.